Knowledge in formal representation. At the beginning, the principle of seeing a simplified world was considered an abstraction of the real world to be modeled. Usually, the principle is to be chosen. The process of conceptualization has stabilized during the development of the means of modeling reality onto the well-established worldview as a set of entities with certain characteristics and mutual relationships. Now at first a generally recognized and application-proven way of using a formal language is given for the sake of building a formal description of concepts and their properties based on the basic, conceptual, level of the model world abstraction. Conceptualization is partially subordinated to the expected formal language syntax. The semantics of the language of knowledge represented in this way of seeing the world ought to be derived from declarative descriptions of the properties and relationships of the entities of the given reference world. They are then formally represented according to the rules applicable in the reference world. From anchoring corresponding concepts on the web or the semantic web, the current state of development has to choose the use of the principle of RDF modeling. Using the RDF data model representation gives a possibility of graphic representation of RDF triples as vectors expressing corresponding knowledge elements. See. Representation of the fact. Marek teaches the subject of PGM languages using a RDF triple and with the help of RDF graph vectors. RDF describes the resource, as a subject, which has some property with a corresponding value, object. The RDF model is based on associative, semantic, networks. In the following figure, we can see the conversion of the sentence Marek teaches the subject of PGM languages. Clearly here we see that the subject is Marek, the object is PGM language, and the property is teaches. The most successfully applied approach to the representation of procedural properties of the modeled world is the output of the process of algorithmic representation of the modeled reality, which builds a formal description of the reference world based on the graphic expression of the formalization, a flowchart of the basic elements of human activity in it. Just as a formalization of declarative knowledge is guided by a conceptual flowchart, procedural knowledge is the guiding factor of the problem of its algorithm, i.e., the way of seeing the process described based on elementary programming language components with special language syntax. The representative language used to simulate the performance of the modeled activity usually has a specific form of a programming language reflecting the characteristics of the modeled activity and the practical application needs. Algorithms typically ignore entities with their properties and relationships, with the interconnection of modeling activities in the process providing data, usually without any closer anchoring in entity representations. The problem solves the following frame approach of modeling. Algorithmic representations of the modeled world with its procedural properties, as well as in the case of point 1, must take into a focus relation to elementary entities and their properties in relationships of a modeled world. It should, therefore, use a representation method based on the RDF model corresponding to point 1, with a terminology relating to entities with their properties and relationships being anchored in the chosen dictionary, ontology, to which access created by the RDF model has been bound. For example, the language UML, as a means of describing RDF modeled reality, would allow UML diagrams to data retrieve into the represented process and their belonging to home entities within the chosen ontology.